Okay, this is going to be part 9 of the video series on trigonometric integrals. Again, another one was secant and tangent. Now, in the last video, we did something that uses part 1 rule here, where the secant was even and saved a secant squared factor. If you haven't done it yet, I would definitely watch the previous videos. But what we'll look at in this time is this second guideline here. It says, if the power to the tangent is odd, then save a secant tangent factor and convert the remaining factors to secant. So we'll be looking for an odd tangent. Now also, just a reminder, you will need some identities on this. So again, we've talked about these before, but the secant squared is 1 plus the tangent squared. The tangent squared is the secant squared minus 1. And then this is particularly important, a reminder on your derivatives. The derivative of the secant is the secant tangent, and the derivative of the tangent is the secant squared. So you'll need those identities also. And the process, though, will be very similar to what we've done in the past videos. Okay, let's look at the problem and see what it looks like. Okay, so what we've got here is this. You've got a tangent to an odd power. So again, let's go back and take one quick look at the rule. And it says, if you've got a tangent to an odd power, save a secant tangent factor. So factor out both one secant and one tangent, and then change everything else into secant. So what that will look like in this problem would be this. We'll come over here. We've got an integral of, now we've got 3 tangents. We're going to take one of them and move them over to the side. So it's going to have 2 tangents left over. So this is going to become a tangent squared of 3x. And we're going to do the same thing to the secant. We've got 3 secants, but we're going to take one of them and move them off to the side. So this will wind up being a secant squared of 3x. So the idea is we took one secant and moved it over here. And then we're going to take one tangent and move it over here. So what that's going to give you is a secant here. You'll have secant of 3x here. Then you'll have a tangent of 3x. And then finally you'll have a dx. So you still got the same thing. You just took one tangent, moved it over here, one secant, moved it over here. And that's what they mean in this rule says when it says save a secant tangent factor. So that's what that's all about. Okay, now again, just like on the other ones, why are you doing that? Well, let's go ahead and we'll put a little box around this thing. But what we're going to do is we'll do this. This part right here inside the red box is what we're going to get rid of during use substitution. And it's all based on the fact, and we'll go back to our identities and derivatives again. It's based on the fact when you've got a secant tangent, remember, the derivative of the secant is the secant tangent. So if we can change everything else into the secant, we'll let u be equal to the secant, use the secant tangent to get rid of it. So it's all part of use substitution. Okay, so the next thing to do is now you've got to take all this part right here and change it into the secant. So let's take one last quick look at the rules. So it says convert the remaining factors to secant, and this is what it means by this. So going back to this, now the problem here is this. This one's already in terms of secant, but this is a tangent. So you've got to change this tangent squared into a secant. And the way you do that would be the following. We'll put, this will be the integral of, now just a reminder on your identities. The tangent squared is the secant squared minus 1. So we use that identity to get rid of this tangent and change it into a secant. So this is going to become the secant squared of 3x minus 1. So this thing here turned into this thing here. So just change the tangent to secant squared. Now you've still got this secant squared. And then you've still got all this other stuff too. So you've got a secant of 3x, a tangent of 3x, and a dx. So these things wind up with quite a bit of algebra. Now the next thing to do is this. This last part here you're going to save for the use substitution. So the next thing is take this secant squared and distribute it across this parentheses. So a secant squared times a secant squared gives you a secant to the 4th. So this is going to be a secant to the 4th of 3x. And then finally, this thing times 1 gives you minus a secant squared of 3x. And then we'll put parentheses around this. And then you've still got the secant of 3x times the tangent of 3x. So you've still got those two. Okay, now I think I'll do one more thing just to make it clear where the choice of u comes from on these. But if we started with an integral, let's take each one of these secants and put them inside parentheses. So this is going to be the secant of 3x quantity to the 4th power and minus the secant of 3x squared. Now, the only reason for doing that is just it makes it real clear on the choice of u. So again, secant 3x, tangent 3x, dx. Okay, now you're ready for the u substitution. So the idea is this. If you let u be equal to the secant of 3x, and it actually shows up 2 places, here and here, let that be u, then the derivative of the secant is the secant tangent, and we can use that to replace all this part over here. So that's going to be our u substitution. So let's go ahead and do the u substitution right now. And we'll scoot this thing down a little bit. Okay, so what you've got, you're going to let u be equal to the secant of 3x. Then find the derivative of that. Well, the derivative of u with respect to x, the derivative of the secant is the secant tangent. So this will become the secant of 3x times the tangent of 3x. And then remember, this is a composite function. It's something more than just a simple x. So you have to take the derivative of the inner part, which gives you 3. Now let's rewrite that. So we'll have the differential of u. Let's take this 3 and move it over here to the front. So 3 times the secant of 3x times the tangent of 3x, and then you've got the dx right here. Now again, you don't need the 3 here for this substitution, so take this 3 and move it over to this side, and finally you get this. 1/3 du would be equal to this. So the secant times the tangent of 3x, well, there should be an x right here, dx. So finally, this matches up with this up here. So here's your substitution. So you're going to substitute 1/3 du. Okay, so we'll continue on with this now. So what we've got in the integral, it would look like this. The integral of, now instead of secant here, you're going to have u to the 4th. So you'll have u to the 4th here, minus a u squared right here. And then in place of the secant tangent, we'll replace it with 1/3 du. So you've got a 1/3 du. Now again, bring the 1/3 out in front of the integral. So this would be 1/3 of the integral of u to the 4th minus u squared du. And go ahead and find those antiderivatives. So this would be 1/3 of, and this would become u to the 5th divided by 5 minus u cubed divided by 3. And then don't forget to tack on a plus c. And you're almost finished. So now the last step is to distribute that 1/3 and change the u's back into what they're equal to. And just a reminder, u is equal to the secant of 3x. So this one will become, when you distribute it, 1/15 times, this would be u to the 5th, but u is the secant of 3x, the whole thing to the 5th power. Then you've got minus, and 1/3 times 1/3 would be 1/9 of the secant of 3x, this time to the 3rd power, plus c. So that's going to be the solution right there. Again, let's back up the front and take a quick look at it. Just a reminder, using the rules, you had the tangent to an odd power. So from the rules, and the rules say, if you got the tangent to an odd power, save a secant tangent factor. So break off one secant and one tangent and change everything else to secant. So that's what you did here. You broke one secant off and one tangent off, then changed everything else over here into secant. Then from that point on, it's just really a u substitution, because the derivative of the secant will give you the secant tangent, and just complete the u substitution, you'll have the final answer. But this is a sample of a problem where you factored out one secant and one tangent. All we're going to do is work a second problem, and the only difference is going to be this, just to show you a difference. In this one, you had to go through this whole long process following these rules. But what we'll do now is do this, the integral of the tangent cubed times the secant squared. So the only difference is going to be changing that secant cubed into a secant squared, but watch what it does to the problem. It makes the whole thing a lot easier, because now you don't have to go through this rule where you factor out a secant and a tangent. So again, what the rule says is if the tangent is odd, factor this thing out. But let's look at the problem and see how you can get around it sometimes. So again, now the only difference, tangent cubed, secant cubed, let's change that to tangent cubed, secant squared. So now you've got a secant squared. Now, if you wanted to, you've got a tangent to an odd power, you could factor out one tangent and one secant and go through that whole process again, and it'd take a lot of work, and eventually you get to an answer. But if you're clever about it, look at the problem carefully. Sometimes you get lucky, and this part right here is already set up for u substitution. So think about your derivatives. Let's take one last look at these. The derivative of the tangent is the secant squared, so you can take advantage of this and do this problem a short way. So let's go ahead and try that. This one you can go directly to u substitution. So what we'll do is this. In this problem, this thing is already set up to be the u substitution. The derivative of the tangent is the secant squared, so you can go a little bit quicker. So we'll make this look like this. Make this one, think of this as being the tangent of 3x. And we'll write it like this, it's quantity cubed. Then you've got the secant squared of 3x dx. So again, let's do u, so you can go to u substitution immediately on this one. So right away, we'll let this part right here be u. So u is equal to the tangent of 3x. Then find the derivative. So the derivative of u with respect to x, the derivative of the tangent is the secant squared of 3x. And then don't forget the derivative of the inside part times 3. So now let's rewrite that. du would be equal to, take the 3 and move it out in front. So 3 times the secant squared of 3x dx. And again, you're trying to get rid of this secant squared dx. Well, you don't need a 3, so move the 3 over to this side. So 1/3 du would be equal to secant squared of 3x dx. Now in your u substitution, this matches up with this, so there's your u substitution, and you're going to substitute this right here. So that means you can now come over and change this into this. The integral, and in place of this, just put u cubed. And in place of this, put 1/3 du. So it turns into a much simpler problem if you can just recognize what you got. We'll bring the 1/3 out in front of u cubed du. And that's going to get you to 1/3. And find the antiderivative of this, which would be u to the 4th divided by 4 plus c. So that's going to get you to 1/12 of u 12th of u to the 4th plus c. And then the last step is just to replace u with what it's equal to. And u is equal to the tangent of 3x. So this would become the tangent of 3x to the 4th power plus c, and you're done. So anyway, the point to be made here is this, is these two problems look almost exactly the same. But before you just blindly start applying these rules here, see if there's not an easier way to get around it. So if you wanted to, you could have used this second rule, but if you did that, you would have had to do all this work right here of factoring things out, using your identity to substitute. It takes a lot longer to get through it. But if you're clever about it and you recognize that secant squared, the derivative of the tangent, is the secant squared, you can go directly to use substitution and save yourself a lot of work. So anyway, just be careful when you start these. Try to see if there's not a quicker way and an easier way to work them before you start blindly applying the rules.